So I start with the first number, what I have, just like before. I don't have much, but it's something. I'm going to split it vertically into 3 slices. And then illustrate what I have. I have 2 of the slices. Not too bad. All right. Now, just like for the chip model, this is sort of the fraction version of the chip model without the negatives. It's all just positive pieces. But it is closer to the chip model. Just like in the chip model, I make a point to not write the second number or represent the second number extra, making it look as if I have more than what I actually have. When it comes to subtraction, the rest of it is merely an instruction for what to do with that first quantity that I have. I only have 2/3. The subtraction then tells me what to do. I need to remove something. So let's leave some space over here. Let's leave a line. Switch to black, definitely. And then say we need to take away 1/5 of a whole rectangle. The problem is, compared to what I see and what I have, I don't know how much to remove. I know I need to remove something. I don't know what to remove. So on this, we're going to draw our horizontal lines according to the other denominator, which is 5. Try and make them as equal slices as possible, but the 5 is always left with some bigger than the other. If you really measure, some are a little bigger, but it's pretty close. It's pretty close. So, looking at the pieces, let's just go. How much do I have? Well, I clearly have 2 columns of 5, so I have 10 pink pieces. 10 pink pieces. Now, it might seem a little strange. Do not draw the 1/5, but in my experience, I run into more problems and more questions, more confusion, because people see another fraction, another bunch of pieces, and they think they have more than what they need. And by they, I mean little Timmy. So now I understand what I need to do. I need to take away something. But what is that something? In reference to a whole rectangle. So I do have some options here. If I've trained myself to look at any rectangle that is split up into 3s and 5s, and just temporarily not see pink. This is just a standard rectangle that can help me translate that last sentence I have. And for that sentence, there is no pink. It's not 1/5 of the pink. It's got nothing to do with pink. There is no pink in this bottom sentence. Now, if you need to, go and draw another one, split it up again, and do everything again so that you don't see any pink. Or you can just train yourself to temporarily not see pink. And of course, that depends on your audience. With little Timmy, I wouldn't even try this. I would draw it somewhere else. Scrap piece of paper, somewhere else that I can throw away, just so I can translate the sentence and see, well, 1/5 of a whole rectangle. How many pieces is that? It's 1 row out of the 5. It's 3 pieces. So 1/5 of a whole rectangle, that is 3 of these pieces. They're not pink. They're just pieces. Now, however, when I look at it as an instruction, I need to take away 3 pink pieces. So we have left 7 pink pieces. So in order for me to figure out what the fraction is that I need to take away in terms of number of pieces, remember we're translating this to integer subtraction. that we then do, and then we translate back to fractions. In order for us to do that, the fraction is in reference to a whole, and I just need to look at a standard rectangle to figure out how many pieces is equivalent to 1/5 of a whole. Then I come back to my instruction aspect and say, okay, so I need to take away 3 of these 10, and I'm left with 7. Now my standard sentence, not pink. How many times is that going to happen? Many, many times. It takes how many pieces? It takes 15 pieces in general to make a whole rectangle. So take note of when the pieces are colored, when the piece is not colored. All of that helps me. It takes 15 pieces to make a whole rectangle. We have 7, so let's say end with 7 15ths of a whole, of course. We had some portion of a rectangle, we removed some of it, so we have a little bit less. Let me zoom out a little bit, or I can fit it all in. Okay, so I just want to do one subtraction. It's very similar to addition, but that could make it more difficult, I suppose, because I want it on the intuitive level to be very different from subtraction. So my presentation should work with the instructions that I have in this case. It's not addition. I'm not going to do the same thing. For addition, I see both of the numbers or both of the quantities and then I do something. For subtraction, I don't. I only see the first one. The rest is an instruction of how to modify that. And it doesn't make sense to me. It doesn't make sense to me to see the second quantity separately. It doesn't make sense. It doesn't fit with the intuitive instructions of subtraction. Now I know that mathematically speaking, there is no subtraction, but this is not what we're doing. Remember, we are staying as left as we can. Let's do number 2. I don't know which one we've done. I'm pretty sure we just did number 1. Okay, so we are doing subtraction, which means I still start with my first quantity, which is what I have. So let's maybe write that down. And then draw it. It's just one rectangle, portion of a rectangle. Well, I have to break it up into 6 pieces. I'll start vertical. It's 1, and then each half into 3. Try to make them as equal as you can. Like so. And we have 5 of them. Not bad, it's something to work with. It's a good portion of this rectangle. Now, as I said before, when it comes to subtraction, I don't represent this other number separately. The subtraction I feel is easier on this intuitive basic level when I see it as an instruction. And the instruction said to remove some of what I have. So let's write that down. We need to take away or remove 1/4 of a rectangle, of a whole. We'll emphasize the whole here. rectangle. There's nothing after the fraction. It's in reference to a whole rectangle for these situations at least. But I then have to figure out, well, what is that? So I go horizontal and break it into 4 pieces to get an idea of how much of the rectangle I need to take away. So let's get some lines here and break it up into 4 pieces. Half and then half again. Just fix my line here. There we go. Now, when it comes to the sentence that I have so far, this 1/4 of a whole rectangle, it's got nothing to do temporarily with the pink. Yes, the instructions are to take stuff away from what I have, but first I have to figure out how much do I have to take away. So I don't look at the pink right now. 1/4 is 1 row out of 4, so that means it's 1, 2, 3, 4, 5, 6 pieces. 6 square pieces. Now I look at my instructions. And I see, oh, I have to take this away from the pink that I have. So let's write that down maybe. Need to take away 6 pink ones according to the instructions. So, well, we have how many pink ones? We have 4 rows, 1, 2, 3, 4, 5 in a row. So we have 20 pink pieces. So that means we're left with, obviously, 14 pink pieces. Now you can add sentences here. Don't take too much away. People tend to want to write as little as possible. And then they're shocked when I don't understand their reasoning and their explanation. You need words to explain stuff. Whatever it is, explanation means words. Use words, and enough words to have any reader understand and follow how you're using this. I have to look objectively at what you're writing down without guessing, pretending I've never done this before. I'm just going on what we write. So there has to be enough to go from one line to the next and have it make sense. No big jumps in understanding or reasoning. So I have 14 left. So 14 pink pieces, that is my answer. But I need to now represent this in reference to a whole rectangle. So I have my standard sentence. It takes, how many do I have here? It's 24 pieces in general to fill or make a whole rectangle. Therefore, so we have left 14 over 24, 14 24ths. And of course, that's in reference to a whole rectangle. If you feel the need to simplify that, do it after the 14 over 24. Simplification is not a part of this. It's not a part of this model. It's not a part of this process. It's an optional thing you want to do if you want to keep yourself busy. But I have no purpose. I have no reason to simplify this answer. Nor does, 7 over 12 doesn't come out of this. There's no 7 here. There's no 12 here. So if you write your answer as 7 over 12 before 14 over 24, then really I don't know if you understand this, because there are no 7s here. There are no 12s in this process. This is not, simplification is not a part of this. So I would prefer that you don't simplify, because it's not clear if you then understand what we're doing here. All right, that is number 2. If I sound a little bit strange, I apologize. Not feeling that great, but I'm hopeful that doing some fractions will make me feel way better. There's really no other way, is there? Let's do number 4. Just so that I have some mixed numbers. Whoops, that's not it. 2 2/3, that's it. Minus 1 7/8. We haven't done 8s yet, so let's do 1. So I have some mixed numbers. Just like in the case of addition, we saw, okay, we just want to be prepared. What if there are mixed numbers? Is there a major adjustment? Yes, no? Let's find out. So I have a little bit more. So I just want to have some space. I'm going to have 3 rectangles here. Whoa, not like that. Trying to make them as equal as possible, because they technically are identical. And then I need to break up the last one into 3, because I don't have a full 3 rectangles. I do, however, have a full 2. So at this stage, there is no need that I can see to break this up and have a lot of lines here and have it look all messy. Just like for addition, we had no need to break these up. And I have 2 of these 3 slices. All right, sounds good. That's what I have. Then I need to take away some stuff. Let's write that down first. Need to take away 1 7/8. Let's write that, expand that a little bit. 1 whole and 7/8 of a whole rectangle. So the 1 whole, let's make it red. Maybe not red, maybe blue. Red and pink look too similar. So if I want to take away the 1 whole, I can just take away 1 whole rectangle that is pink already. But when it comes to the 7/8, I don't know how much of the pink I need to remove. The 1 whole was straightforward, the 7/8 is not. So just like before, I need to see here a little bit. What is this? What is this? For that reason, I'm just going to take a rectangle and split it up into 8 pieces horizontally, because I've done vertically already. Now 8, I don't want to go too high with denominators. 8 is perfectly fine. So do practice 8, but don't go above 10. Let's go here, and then I split the half in half. And then I split each of those in half. So it gets a little thin, which is why we don't want to do denominators that are too big, then this falls apart. You can clearly see that. This diagram method isn't going to work for much longer if my numbers get bigger in the numerator or denominator. So there's a shelf life on this guy. We're not going to be able to do this for very long, so don't worry about going above 10. So when I look at a whole rectangle, this one for example, 7/8 mean I need to look at 7 of the 8 rows. Each row has 3 pieces, So I have 21 of these thin little pieces. Just sort of as a side note. I could do something with the whole already, remove that, but I still have to remove 21 pieces. Now you see over here, how many pieces do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. I have 16 pieces that are pink. So I can think ahead a little bit. It's like, oh, I need to take away 21. I don't have enough. I'm going to have to dip into this middle whole rectangle. I need to remove some of that as well. So for that reason, I need to break this guy up as well. I didn't know that until now. Maybe I didn't have to break him up. But in this case, because I have to remove so many, I'm going to have to cut into this middle loaf of bread. So let's do that. So I split it up in exactly the same way. 3 pieces vertically, 8 pieces horizontally, half is cut in half, is cut in half, half of a half of a half is 8, or is an eighth. Alrighty, there we go. But understand why I needed to do this. I wasn't going to do it just for the sake of it. There's no need for that. I have to do it because I need to remove more than the pieces that I have in this last one. If for some reason the fraction wasn't that big, I only had to remove 16 or something else, 12 maybe, then I didn't have to break up this middle one. I have enough. Already, so now I have to remove. Let's do that. So what you could do as an option is you could actually start crossing them out for little Timmy. Okay, I need to cross out 21 of them. 1, 2, 3, 4, 5, 6, 7, 8. Now what seems tedious to you might be very helpful for little Timmy, and give him some time to systematically understand this taking away process. Count them off. Know your audience. We maybe have the flexibility to maybe just do a subtraction, count all these pieces. I have 5 columns of 8, so I have 40, and I can just do 40 minus 21. But for little Timmy, that might not be what he's ready for. You have to adjust according to your audience. So I crossed out 16 so far, 17, 18, 19, 20, 21. And then we can count. How many do I have left? Well, 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19. So there are different ways to get to that 19 pieces that are left. So, because we've demonstrated here, we don't need that sentence, I think. We have left, whoopsie, not pink. Ooh, that's a nice color. We are left with, what did I say? 19. 19 pink pieces. Now I still have the problem of rewriting this in its corresponding fraction form, referencing a whole rectangle. So I have my standard sentence. It takes 24 pieces to make a whole rectangle. Count them off if Timmy needs to do that. If Timmy after a while starts to notice, oh, it's always the denominators multiplied together. That's for him to discover, not for me to force on him. There's something very effective about just slowly counting and letting the discovery take place. You can't know how much time that other person needs. It takes 24, so we are left with 19 24ths of a whole rectangle. Luckily, in this case, you can simplify it even if you want to. So, haha, I don't want to simplify anyway. And there we go. Subtraction, different on the basic intuitive level for sure, but it's very much on the same level as addition in terms of difficulty.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.